Okay, so now let's look at adding vectors or using a component to add vectors. So we have a vector, we'll call it vector A, vector B, and we are supposed to find a resultant of these two vectors. So what I'm going to do is first I'm going to actually draw that resultant in here, because we all know that if we use the graphical method, this would be my resultant. Okay, so I know that this is my vector A. We'll call this vector B. And so in this case we know that resultant vector equals vector A plus vector B. Right? Now the key idea around component method is that if this is my AX, this is my AY, and if this is my BX, and this is my BY, this little guy, the orange one, then the complement method says that the X component of the resultant will equal to the sum of X components of these two vectors. And the same thing goes for the Y component. Right, so what is nice about this is that now we have a recipe that tells us that the sum of the vectors, the X component of that sum is the sum of all X components of the vectors, and the Y component the same thing. So we have a very easy way to find out resultant here, and then if we would want to just find the magnitude of that resultant, then we would use Pythagoras theorem, and we would use the trigonometric ratio for the angle, right? So I know that this would equal Rx squared plus Ry squared, and I know that tan of the angle would equal to Ry magnitude divided by Rx magnitude. Right, so super easy. Now what is nice here is again to realize that these components, as we are adding them, they are one-dimensional case, right? So let's keep in mind that if the vector would be in the opposite direction, we would still need to consider the signs, but it's certainly to add vectors in one dimension becomes a very easy task. When will you use this component method? Really for multiple vectors. Imagine you have 5 or 6 vectors. It's really hard to predict which way something's going to move. So that's when you say, hey, if I need to add 6 vectors, I'm going to find components of those 6 vectors, add up all the X components, add up all the Y components as vectors, and the problem is solved. I will add these vector signs here just to be consistent, because those components themselves are vectors as well.